Alright, in this video we're going to be talking about antiderivatives with log. Let's recall the derivative of log. The derivative of the natural log is 1 over x. And so the integral of 1 over x is going to be the natural log of x plus c. Now we do have a bit of a domain issue. You'll note that when we're differentiating log, the domain of log is, 0 to infinity. However, the domain of 1 over x, it's negative infinity to 0 and 0 to infinity. So it's all numbers except 0. So we need to adjust the domain of the natural log so that it includes negative numbers. And how we do that is we introduce an absolute value. That makes this natural log exist on all non-zero numbers. Okay, so let's do some examples. First example here, we're going to be integrating 1 over 5x plus 2. Okay, so we don't have 1 over x, we have 1 over 5x plus 2. So we have an inside, which is 5x plus 2. Let's call that u. And then we'll find du. du is going to be 5 dx, or 1/5 du is going to be dx. So now we can convert this integral. We'll get 1 over u times 1/5 du. And the antiderivative of 1 over u, using the formula above, is the natural log of the absolute value of u. The 1/5 is just a coefficient, and we add a plus c. Now that we've taken the antiderivative, we can back substitute in our x, and we'll get 1/5 natural log of 5x plus 2. And that's our answer. All right, let's do another example. So in this problem, we have e to the 2x over 4 plus e to the 2x. Okay, so this one's a little tricky. You might have to think about it for a bit. I encourage you to stop the video and spend a few minutes thinking about how to do this problem. All right, we're back. So the key to this problem is to identify the denominator as u. So we'll call 4 plus e to the 2x u. We'll differentiate, and we'll get e to the 2x times 2 dx. And now we see that this is really a 1 over u type problem. That denominator is just u, and then the numerator is our du up to a constant. We need to adjust it slightly, so we'll need to multiply both sides by a half so that it matches what's left over, this e to the 2x and dx. And then we'll get 1/2 du as the top and u as the bottom. We can write this as 1/2 times 1 over u du. And the antiderivative of 1 over u is the natural log of the absolute value of u. The 1/2 is a coefficient. And we can now back substitute and get 1/2 natural log of 4 plus 2 e to the 2x plus c. Okay, so let's do another example. Let's integrate the natural log of x plus 5 cubed all over x. Okay, again, we know u substitution applies here because we have an inside. The inside is this natural log of x plus 5. So we'll call that u. And then du is going to be 1 over x dx. Converting my integral in terms of u, I'll get u cubed. The dividing by x I can write as multiplying by 1 over x. And then that becomes just du. And then I antiderive u cubed. I get u to the 4th over 4 plus c. and then I back substitute, and I get the natural log of x plus 5 to the 4th power all over 4 plus c. All right, I hope you found this video useful.